Lesson 1. School of Elements. Dear friends, last year we have learnt that matter can be classified chemically. Matter can be classified into three types: elements, mixture, compound. Please see that frying pan and griddle are made up of iron, and wires are made up of copper and aluminium. All these things are made up of elements. See, the statues and medals are made up of bronze, which is an example of mixture. Sugar and salt are examples of compounds. We have revised some part of last year. Matter can be classified into three types. At present, 116 elements are known. Out of these, some are found in nature and some are man-made and short-lived. Elements are classified into two types: nature-made elements and man-made elements. Nature-made elements are those elements which are found in nature. But classification of elements as nature-made elements and man-made elements is not sufficient. As more and more elements are discovered, it became necessary to study their names, properties, uses by the scientists. In the early days, the elements known at that time were classified into metals, non-metals, and metalloids. Iron and aluminium are metals. Hydrogen, oxygen, nitrogen are non-metals. Silicon and germanium are metalloids. What are we going to learn? First attempt to classify elements by Dobrunner's triad method. Then, Newland tried to classify elements in a similar way of musical octaves. Mendeleev tried to classify elements systematically and scientifically. Arrangement of elements according to increasing order of their atomic masses. We are going to learn the modern periodic table for systematic study of elements. We are going to study different blocks and elements in those blocks. We are going to study different types of elements and their electronic configuration. We are going to study three subatomic particles: protons, neutrons, and electrons, which are essential in chemical reactions. We are going to study classification of elements based on their electronic configuration. We are going to study four types of elements, namely normal elements, inert elements, transition elements, and inert transition elements based on their electronic configuration. Dobrunner's triads. In 1829, John Wolfgang Dobrunner, a German scientist, found a group of three elements that showed similar properties. The atomic mass of the middle number is the approximate average of the other two. For example, if we take a group of three elements, lithium, sodium, and potassium, the atomic mass of lithium is 6.9, sodium is 23, and potassium is 39. The average of lithium and potassium, that is 39 plus 6.9 divided by 2, equals 45.9 divided by 2, equals 22.9, which is 23. Now see, in the triad, the average of lithium and potassium is equal to 23, which is same as the atomic number. The average of lithium and potassium is the same as the atomic mass of the middle element sodium, which is 23. A similar example is for a triad called calcium, strontium, and barium. One more example chlorine, bromine and iodine. Sulfur, selenium and tellurium is another set of triad. This group of three elements is known as Doberian's triads. He could identify few triads. Other triads did not obey this. So the system was not accepted. Newland's octaves. Then came Newland, a British scientist. He arranged the elements according to the increasing order of their atomic mass. He found that 8th element resembles the first element in its properties. He classified 56 elements known at that time. This resembles the octaves of music. Hence, it is known as Newland's octaves. Newland's law. When the elements are arranged in an increasing order of their atomic masses, the properties of the 8th element are similar to the first. Some features of Newland's octaves. Out of 56 elements known at that time, he could classify elements up to calcium. After calcium, every 8th element does not show similarity in their property. In order to fit the existing elements, Newland placed two elements in the same positions which differed in their properties. This periodic table did not include inert gases. Hence, it was not accepted at that time. Mendeleev's periodic table. Dmitry Mendeleev, a Russian scientist, believed that the properties of elements are the periodic functions of their atomic mass. He considered the reaction of element with oxygen and hydrogen. He arranged elements in the increasing order of their atomic mass. He found that elements show repetition in their physical and chemical properties after certain interval. He arranged known elements in increasing order of their atomic masses in horizontal rows till the element had the similar properties to the first element. He placed this element below the first element and thus started the second row of elements. He created periodic table of 63 elements. Mendeleev's periodic law. The physical and chemical properties of elements are a periodic function of their atomic masses. Main features of Mendeleev's periodic table. There are 7 horizontal rows known as periods. Regular gradation in their properties is observed in the same period. There are 8 groups. Elements in the same group resemble in the properties. Groups 1 to 7 are further divided to A and B.